Hey guys, and welcome back to Dan's Pro Shop, where everything's made up and the instructions don't matter. Well, at least for this one, they don't matter only if you don't want them to. This one is actually brought to you by a lot of your suggestions. If you guys have seen my stuff before, you know that I preach the use and knowledge of a multimeter, and I've talked about them quite a bit. But I haven't really gone over just the ins and outs of simply how to use one and how to use one correctly. So you guys have actually asked for it, just a basic entry-level instructional video about a DMM, what it is, and how to use it. So I've put together a little simple something. Actually, my 8th grade science teacher would be so proud of me because I actually prepared for a presentation. So let's get into this a little bit and see what we got going on today. So first things first here, let's just go over the basics of a DMM. And when I say DMM, I mean digital multimeter. It's just like anything else, there's an abbreviation for everything in this world. And you guys see here the selection dial. This can get pretty complicated or intimidating if you don't know what you're coming up onto. Now you guys see here there's a lot of different stuff available on this dial, but this is super run-of-the-mill stuff, and this is just the signage and symbols that we use to reference different units. Now you guys can see here's a different meter, has almost all the same symbols on it. It may vary some, but usually no matter what meter you get, these are the symbols you're going to run across. And for sake of time and simplicity here, we are going to go over the 3 most commonly used things on a multimeter. Yes, there are hundreds if not thousands of different ways that you can use one of these things, but for beginner entry-level stuff, let's talk about the main 3. And those 3 are voltage, amperage, and ohms being resistance. So you guys see here the V, that obviously stands for voltage. And the wavy line above it, that stands for alternating current, or AC. Now that wavy line is a good indicator to let you know that's AC because that depicts a sine wave that goes up and down. The alternating current alternates. This is a really good depiction in just explaining what that means. Right to the left here, there is a straight line above the V, meaning this is direct current. The current goes directly from point A to point B. It does not alternate like AC does. So you have to know which unit you're trying to measure here and tell the meter, hey, I want to read DC, I want to read AC. So you see here this selection, millivolts, has a straight line and a wavy line above it, indicating that this selection will read AC or DC. So right now it's in auto ranging and DC. If I want this thing to read AC, I have to tell the meter that's what I want to see. So I go down here to the function button. Now we're reading AC millivolts. But if we go down to the ones that only have one thing, you see here this is volts DC. You can hit this function button until you're blue in the face because we're only getting DC. Down here with the volts AC, same thing. You hit this function button all day, we're only reading volts AC. Now moving up the dial here to this upside down horseshoe looking thing, or the omega symbol if you're big into that college stuff. This stands for the unit of ohm. And this is how we measure resistance and are able to do continuity checks in wiring. So let's say I had this length of wire here and I suspected it being broken in the middle somewhere. How you would test that is by using ohm. So you take 2 leads here that come out of the top of the meter and put something in between them. So let's just imagine here that there's a wire between these 2 probes. Oh, that 0 tells me that there is 0 ohms of resistance between this lead and this lead. If there was something bad, I would get some kind of number here. You see, just the tip of my finger has 30 some odd, 20 some, 30 some ohms of resistance between these 2. Once I let go, out of limits. That's what OL stands for. Some you may see OFL, which means out of field limits or out of freaking limits. It depends on how mad you are at the project that you're doing. But the basis of ohm here is that you can check resistance between one point and another. This is a big thing for checking fuses, because if a fuse is bad, you will read OL, meaning that there is no contact between one side of that fuse and the other. But if a fuse is good, it will be just the same as touching these two together. So this is a really good and easy field check to know how to do, especially for checking fuses. So let's skip right past this farad stuff because that's a lesson for another day, and head right up here to current. So you see MA, that is the exact same thing as MV. This just stands for milliamps. This one is regular amps. This just changes the ranging. You see the decimal place here? This is just a much smaller and more accurate measurement of current. This is the one that you would use most of the time, but whenever you need something to get really down into the decimal places, that's what you use milliamps for. So let's go ahead and check out this little sketchy rig that I have set up here and do some practical application. Now guys, what I have here is just a regular old light bulb and a base. This is strictly for example only. Hey, you guys read the disclosure at the beginning of the video. If you choose to do this, that's on you. Nothing about this is safe, but we need access to these terminals for the purpose of this video. So all I did, like any good tinkerer or hobbyist, you would have what we call a suicide cord. Something with male ends on both ends, simply for testing and diagnostic and stuff. So what I have here is just a regular 120 volt male plug that will go into the wall, and I have some alligator clips on the other side of it. So I'm just energizing this light bulb base here so we can use this for a load and we can do some different measurements with the meter. So let's go ahead and plug this guy in. There you go. We got a light bulb as expected. Flip this thing over. We now have two live contacts here. Now, if we wanted to check for voltage, this would be the same for anything. If you want to check the voltage in an outlet or a light bulb socket, anything, everything, this test will be just the same. So we know because residential electricity that comes out of your wall is alternating current 120 volts at 60 hertz. I know this is getting a little more in depth than we planned here, but standard North American electricity, that is what we're going for. Right out of the wall, voltage AC. So you want the squiggly line over the V. Bob's your uncle. Let's get tested. So when it comes to multimeters, think about the battery cables on your car. The red is power or hot. The black would be ground or neutral. Now, I know when it comes to AC, ground and neutral are not the same thing. But for DC, you have power and ground. For AC, you have power and neutral. But, I mean, it gets bonded back at the panel. But, like I said, we're diving a little deep. Let's just do the simple test at hand here. I want to take my two leads here and connect one to one side and one to the other. You see the meter there? 123 volts AC. This is exactly what we expect to see. The chance of you ever seeing exactly 120 on here are about plumb to none, because you have voltage variations, you know, the transformer outside, the regulation coming from the power plant, anything and everything. There are a million variables that come between this number and what the power plant actually puts out. But what we're looking for is pretty well close to 120. So if you get this number, there you go. And really, if you're doing this stuff, this is more for troubleshooting. Like, hey, why isn't this light working? Or why isn't this socket working? This is really the purpose of this. So all you need to know is that whenever you come into an AC source like this, like let's say this light bulb isn't working and we need to check this socket, let's flip that over and do that test. So now, let's just say that this is a bulb hanging in the ceiling. I know it's upside down, but whatever. So let's take our probes, touch one side, then touch the other. You see there, 124 volts inside the socket. That would be a good way to test this thing sticking out of your ceiling. Like, hey, I know this is good. So it eliminates all of that question, like, is it the switch? Is it the bulb? Yada, yada, yada. So now let's move on to something slightly more complicated, and let's measure current. This is where a lot of people start getting a little sticky with this stuff because it's slightly more involved. Voltage is super easy. You put it on what you want to read, you touch what you want to read, you get a reading. With current, there's a little more involved. Let's look at the top of this meter and explain what I'm talking about. Now, like I said before, all the different selections on this dial here do different things. But there are some things that you need to keep in mind. Voltage and amperage are two very different things. And whenever it comes to this meter, it expects you to know that difference and anticipate how to properly set this up. What I mean, you see all the ports here on top? Common, black. That one is super easy not to mess up. Your black lead goes in the common, and it pretty much stays there for always and eternity. However, going from amperage to voltage, you have to change the location of your hot lead. This one, like I said, microfarad, that's a different thing. That's a story for another day. But we're talking about voltage and amperage. So there are different circuits inside of this meter that measure different things. If you try to measure current while you're still plugged into voltage, guaranteed, like death and taxes, you will blow the fuse inside of this meter. And yes, they are fused. They're only good. Most of them are good for 10 amp. I don't remember exactly what this one is off the top of my head here. Oh, here you go. 11 amp max. That means that this circuit, inside of this meter, there is an 11 amp fuse. So like you can't go and charge your Tesla while it's hooked up to this thing for a current reading. That's also another story for another day. But the moral here, whenever you're switching between voltage and amperage on the dial, you also need to switch between voltage and amperage with your probes. Alrighty, now we have our dial set to amperage, and we need to change this to AC because we're doing the same thing. So now we are amperage, AC, and we have our probes in the correct location. Let's get to this test. So just like we had to move our leads on the meter, there is also a little extra involved in doing a current test. It's not as simple as just touching these together. We actually have to interrupt this circuit and put our meter in series. Now, when I say in series, that means this meter has to be in between the source and the load. I know I'm using a lot of terminology here, but let me tell you, this is super basic once you get into this stuff. The source of the power being the outlet in the wall, the load being the light bulb. So I need to put my meter somewhere in between the source and the load. Parallel would be what we did with the voltage test. That just means I'm reading what is there. We don't have to change anything. Series is a tad more involved. But luckily with these little alligator clips here, it's not that much involved. But to do a current test, we need to remove one of these wires and put our meter in series. So simply, all I'm going to do here is remove one of these alligator clips, replace it with one of the clips from my meter. Now the other meter will go to this alligator clip. So essentially what I have done is really put a wire in between this and the wall. So now the electricity will come through the plug. It'll come out of the outlet of the wall, through the plug, through here, up through this lead, through my meter, back to the light bulb, and then back to the wall. So we have a good series connection that will read what's going on inside of this bulb. Let's plug it in and see what the meter has to say. Contact. So you guys can see here our bulb is illuminated, and now we are measuring current. Now you see how this is so small here. It's 0.109. Like we're talking milliamps here. It's not even one full amp. But for the majority of tests, this is going to be good enough. And honestly, this is so small. If you're doing a legit current test, stuff like this wouldn't be that important. Like whenever you get onto bigger stuff like pumps and motors, now we're measuring like 30, 60 amps, whatever. But in this case, whenever you have something that's lower than this decimal point, that means we're dealing with milliamps. Let's go ahead and go down to that milliamp selection, tell the meter that we're reading AC. Boom. There you go. We are right about exactly 1 milliamp. And that's how much power this light bulb is pulling. Now check this out. I'm going to unscrew this light bulb, not unplug it, not do anything. Just unscrew the light bulb and watch what the meter does. Check that out. Dropping down into the basement. Now, if I have this back where it was on the regular amp selection, you see here, it's really the same thing, it just moves the decimal place. But you see this number dropping down into the basement because there is no load. This circuit isn't using any power. It's not using any current. Now, if I plug or if I screw this light bulb back in, you'll see that number shoot right back up because we're utilizing the current in this circuit. Like I said, this is a little more involved and not as commonly used for like regular everyday people. But this is a super awesome thing to know how to do. And last but certainly not least, we are going to go over the unit of ohm. Because like I said before, this is arguably the most usable thing on a multimeter. Now, whenever you go from amperage or current test, one of the biggest things you need to remember, not only do we switch the dial, we need to switch our leads back to where they're supposed to go. So, since I'm going from current to ohms, I switch my leads back and now we're ready to do this test. So, let's take a random piece of wire here, just strip the ends of it off so we have some exposed conductors. Now, let's say I suspect this wire of being bad or broken in the middle. I will take my meter and hook it up to both sides. So you see here, I have 0. And with this particular one and a lot of other ones, you can choose whether you have a tone or not. So you have something audible to go along with the visual reading. This is nice if you're in a place or in a situation where you can't see the screen, or if it's dark or whatever. It's just nice to have that little thing. So right now we got a tone and a 0 reading. That means this wire is good. It's perfect. It couldn't be any better even if we wanted it to. Put it together. That's what we got. Now check this out. If this wire was broken, no good, man. This is a super valuable test to check for broken or damaged wires. Now, with that being said, this test only goes so far with diagnostics. There is another thing called a voltage drop, which is kind of a variation of this test where we just looked at this wire, but it goes a little more in depth. Whenever we're doing a voltage drop, yes, we are checking to make sure that this wire is connected from one side to the other, but we're taking it another little step. You guys see here these stranded wires inside of a regular old piece of wire, which is more often not what you'd run into. I mean, not in residential situations with like Romex and stuff, but regular, I don't know, I would say 80% of the applications you run across, you're going to have this stranded wire. Well, think about it this way. If one of these wee little strands is connected from one side to the other, and we do this test that we just performed, checking continuity between one side and the other, we're still going to get a good reading on here because one of these wee little things is connected from one side to the other. But let's just say that this thing is hooked up to a 10 amp fan circuit in a Bobcat or something. Do you really think that one of these wee little hairs is going to carry 10 amps of current? I don't think so. This is just going to pop like you wouldn't believe it. So we do something called a voltage drop, where we go into the voltage setting, measure the voltage between one side and the other. Now, I guess in order to explain this test a little bit better, I need to explain how meters read electricity. So, in essence, what a meter does is it reads the differential in power, something between this and this. And that's quite honestly how this ohm test we just did, because it reads the potential difference between one lead to the other, and it saw 0 amount of difference, meaning that both ends of this wire are at the same potential. So think about this way. If this wire had 120 volts on it, and I put my meter between here and here, it would still read 0 because there is 0 potential difference between the two places where I put these. So if I had a bad wire in between here, it's still connected and works with the ohm test, but I have a 120 volt source on this side and my load was on this side. I would check between here and the other side, and you will get a number on that screen. It will no longer be 0. You will see something. You might get 30 volts, you might get 50 volts, you might get 110 volts, whatever. It is measuring the potential difference between this one and this one. So anything other than like maybe 1 or 2 volts on a voltage drop test, you know this wire is bad and it needs to be replaced. Let me tear this thing apart and see if we can't create something similar to that so you guys can actually see how it works. Alright, so what we got here is a regular old piece of wire on 2 ends, and you see that I stripped a piece in the middle. Yeah, I nicked it a little bit, but for the purposes of this test, it's fine. Let's go ahead and do a continuity test with our ohm meter. So, this measures almost nothing, negligible, right? Almost exactly 0. So I know that this wire is good from side to side. Let's do a voltage drop test on this wire. Alright, so now we have our little test circuit set up here. I have that piece of wire wired in series between the pigtail and the light outlet here. You can see that it's on. So in order to do a voltage drop test, I need to measure between here and here, the 2 sides of the wire that I'm wanting to measure. So now that I have my meter in voltage AC, we'll take our 2 leads and touch either side of this wire. Ideally, you want to see the minimum number that you can, if not 0, because that's what we're shooting for. So we touch one side of this wire and the other. There, see there we have millivolts. Almost absolutely nothing. So yeah, half a millivolt. Almost nothing. That is perfect. That's letting me know that this wire is conducting good electricity from one side to the other. So not only does it pass the ohm test, but I am losing minimal voltage from point A to point B. Now, let's take this bare spot in the middle here and jeopardize the integrity of that and bring it down to just like 1 strand. Do this test again and see how drastically that changes this reading. Alright, now you guys can see here, maybe not, maybe yes, I cut all of those strands in this wire except for 1. So, just to prove my point here, let's go back to ohms. I'll give you some noise so you can hear it. Now, the circuit is dead, so there's no electricity on it right now, but let's check for continuity between point A and point B. You see that? Almost nothing. The same thing as we had before whenever this wire was perfectly fine. But this could be misleading. So an ohm test says that this wire is good, but we know better, and let's prove that with a voltage drop. Switch our meter back over to voltage AC, plug this back in and perform that same drop test as we did before. Okay, you guys can see here, the light bulb is on, the circuit is working, but the whole thing is hinging on that wee little piece of strand right there. Let's do this voltage drop test and determine the difference between this one and before. So we take our meter just like before from one side of the wire to the other side. Holy crap, you guys see that? 20 volts, 19.5, 20 volts. There is a potential difference between this side of my meter and this side of my meter of 20 volts. There is so much resistance and loss of current between here and here because of how bad this wire is, the damage, whatever situation you may run into. We are losing 20 of our 120 volts from this side to this side. I know I probably should have used an incandescent light bulb here to better illustrate this because it would be like really, really dim. But I had an LED, so this is what we're working with. But the point of this test still proves itself. You see here from source to load. 20 volts. That is absolutely crazy. Just from damaging this wire, we lost all of that potential energy. And this really goes in to energy savings and stuff. If you can go and do stuff like this, you might be able to honestly save yourself some coin. Now guys, I know I may have gotten a little long-winded in some of my explanation here, but if you can't tell, I'm super passionate about this stuff. And honestly, this is stuff that I do every day. Now, you may not run into the same scenarios as the stuff that we went over here today, but knowing the basics of a DMM can absolutely change the way you live your life. And like I said before, like these meters here, these are just examples. This is stuff that I had closest to me when I decided to make this video. So, like we went over with the dial selections. A lot of those selections are like per meter. So it depends on what kind of meter, what brand of meter, what grade of meter. Like really what you're trying to get out of it is what it will give you. I don't know if that's a good way to explain it, but yeah, a lot of these are like the basic normal that you would see in everything. And I think understanding those main three, voltage, amperage, and resistance, are the biggest thing, and that can really get you out of probably 90% of the issues that you're going to run into. So like I mentioned, there is a lot more stuff to do with this, like measuring capacitance and all this and that, but this isn't an electrical engineering course. This is a, hey, I've never seen one of these before and I kind of need to check a fuse on something. So really just out of the box how to use one. So if you guys are interested, I will link in the description a couple of my favorite meters for different situations so you can check it out and get one for yourself if you don't have one. If you do, awesome. Hopefully this helped you out, maybe get through a little sticky point that you may have been in. But really, I cannot stress this enough. Electricity is around us. It is our world. And even understanding it a wee little bit is so useful. You know, you don't have to be on the phone with the repair guy at 2:30 in the morning because something quit working. You know, go in the garage, grab your meter, do some preliminary diagnostics. It might be something as dumb as a blown breaker or a bad fuse or something, but you can be the hero and get the lights back on. You know, this stuff is so important and I can't stress it enough. So hopefully this genuinely helps somebody out there, and we will see you guys next time.